All right, algebra, college algebra students, what we're going to be doing now is moving into section 3.2. A lot of the material is familiar to things we just did in section 3.1. However, what we're going to be doing is concentrating on a graph of a function. So far we've been able to do a lot of things. If I gave you a function in, let's say, a form that's nice in an equation form, or if we gave you a table of data, or if we gave you a schematic. All right, so we've actually been looking at functions in that, but in 3.2 we take an explicit look at the idea of a function and information from it if we have a picture of a function. All right, and hopefully it's no stretch of the imagination. We already know that behind every equation there is a graph. Right, so behind all these graphs you see, there's some function, right, equation somewhere in behind the scenes. But we'll cover that as we go along. But for sure, how do we answer questions if the function is given as a graph? So basically, same idea, just new way to write the function. So the first thing we want to do is state whether or not a relationship that's shown, right, in any thing here, is it functional or not. And again, all we have to do is test the idea that 1x creates 1y. All right, that's basically our definition of a function. One thing in, one thing out. If we have a data point that doesn't do that, it ruins the functionality. So it's the same definition, but visually there's a really nice way we can see that. So if we take a look at this, right, -4 creates that output. -2 creates that output. -1, 0, and 1, they all seem to have one thing in, one thing out. But then we come to x equals 2, and we notice that for that value, right, for x equals 2, there's actually two values of output, 3 and -4. So this makes us a non-function. It's still a relation, right? Everybody's a relation, but this would be a non-function because I have a situation where an input, right, basically creates two outputs. So that ruins the functionality. Of course, another way of saying this is if I drew a vertical line, right, x equals 2 would be this vertical line right here. We notice that this vertical line actually intersects data twice, right, which just again verifies that one thing in, two things out. And all the other vertical lines, right, basically you only pass once. So everybody else is fine, but 2 ruins it for everybody. So this is a non-function. Again, if we think in terms of a vertical line test, every data point that I have, right, every vertical line only crosses through once. So every x has one y, right? This x has this one y. This x has this one y, and so forth and so forth and so on. So this is a function, right? If you want to, you can say passes the vertical line test, all right? Or 1x gives 1y. However you want to say that, that's basically what's happening in that little data, that scatter plot. Every x value has one y value. Same thing for letter C. We're going from a discrete situation like we have in the first two, and this is a nice continuous function, if you would. All right, and so again, it passes the vertical line test. Every vertical line that you and I can draw will cross that axis, will cross that graph just once. What that means is if x is -3, there's only one output, right? If x is 2, there's only one output. If x is 5, there's only one output. If x is 4, there's only one output. If x is 10, there's only one output. So this passes, you can say it this way, the vertical line test, or 1x is creating 1y, however you want to say that. But this is definitely functional. All right, so we have a nice functional relationship. In part D, again, if we just look at it, vertical line test, we can see that every vertical line I basically use will cross that twice. Or said another way, if x is equal to 3, right, there's basically two y values associated with it. As a matter of fact, it seems like every x, right, all x have two y. All right, and so that makes us a non-function. So this one fails the function test miserably, right? Every value of x creates two outputs, and this is definitely a non-functional situation. Last two graphs, again, if we think in terms of vertical lines, right, every vertical line basically crosses this graph once. What's interesting is that x equals to 1, there seems to be a very interesting attribute happening. I believe we've seen that in some future or some past things. It's a vertical asymptote, and those usually occur when there's a division by 0 there. So that's going to get to domain in a moment, but with the exception of 1, which is undefined, it seems like every value of x, right, 1x creates 1y, or you can say passes the vertical line test. So this is a function, right, because 1x creates 1y, even though x equals 1 is a little bit of an outlier, but that's a different question. And then letter F is pretty tough, all right. This one, this is your first idea of what we call a piecewise function. And for this piecewise function, again, we're just looking for every x, right? Every vertical line seems to cross once. Again, the one discrepancy is at 1, right? So at x equals 1, let's kind of get a good idea how many y values do I actually have? Because if it's 2 values, we're non-functional. If it's 1 value, then we are. And what's important here is you realize that up here, that circle is open, meaning we're not allowed to be equal to, and this circle down here is closed. So what that's indicating to me is if my input is equal to 1, our output is -7. So one thing in, one thing out, passes the vertical line test, right? Whatever you want to say. Even the point that seemed a little interesting, this, despite that little break, is a function. If I was to close that dot, if this would be closed, it's now non-functional, right? Because x equals 1 would give us y equals -7 and 4 respectively. But because this is open, we're not allowed to be equal to 4, right? Because this is closed, we're allowed to be equal to -7. So there's how we answer the old question, am I a function or not? Again, it comes back to the idea of 1x in and 1y out, or visually what we now can use is the vertical line test. If it passes the vertical line test, you're functional. If it doesn't pass the vertical line test, you are not. The next thing we're going to talk about here is now that we have a nice visualization, we can clearly see domain and range. But I'm going to do that in another video, so let's cut away from this, and I'll see you guys in the next one.